Section 4.3 is on rational inequalities. We're talking about taking a rational function, r of x, and determining when it is greater than or equal to 0, or when that rational function is strictly greater than 0. And then, of course, any of the other two possibilities. Maybe it is less than or equal to 0, or r of x is less than 0. And so the guidelines are pretty straightforward in this section. So let me lay them out for you. Step number 1, if not already, get all terms on one side of the inequality, so that your inequality is relative to 0. So if you have multiple terms or terms on both sides of the inequality, first thing you want to do is bring all your terms to one side. So get all terms on one side. The next thing that you want to do is, if not already done, get a common denominator. Get a common denominator, simplify the rational expression, the rational function, and factor it completely. Number 3, you're then going to make a sign chart. For r of x. And then step 4, choose the appropriate intervals and x values. So let's take a look at this process. Let's see. Example number 1 is a pretty straightforward example. Solve the inequality 3x squared minus 5x minus 2 divided by x squared minus 9 is strictly less than 0. So we actually looked at this function previously. We graphed it actually in our last graphing example in section 4.2. But we want to take a look at its sign chart here. So step 1 is already done. That is to say, I already have all terms on one side of the inequality, so it's relative to 0. So everything's on one side, and I got 0 on the other side. Excuse me. Step 2 here is actually already done. I already have a common denominator. It's all combined into one giant term. What I need to do is, I guess it's not all done. Let's see here. Common denominator. Oops. Check, we have that. And then it says simplify it. Oops. Simplify. Check, it's simplified. Factor. This factors previously from our factoring in the last example. This is 3x plus 1 times x minus 2 divided by x plus 3, x minus 3. And we want to know, when is this less than 0? So now I have it in factored form. Check. Here it is in factored form. So now we're going to do step 3. We're going to make the plus minus sign chart. So how do we do that? To make the plus minus sign chart for f of x equal to 3x plus 1, x minus 2, over x plus 3x minus 3. We need the critical values. And those are the values that make the top or bottom 0. So those were x equals negative 1/3, 2, and plus or minus 3. And then we're going to take these values, use these to break up the number line into intervals. So it'll look like this. Here's negative infinity, here's positive infinity. Let's see. Negative 3 is going to be the furthest left, then negative 1/3, then 2, and then 3. Now, this isn't to scale. I'm just kind of placing them on the number line in order, and that breaks the number line up into a few different intervals. This is the interval negative infinity to negative 3. This is the interval negative 3 up to negative 1/3. I would say this, some students I noticed when I was grading the exams have a real hard time between distinguishing the difference of between a point and an interval. These are intervals, not ordered pairs. This is from negative 1/3 up to 2. This is 2 to 3. And then this is 3 to infinity. Okay, now what we're going to do is we're going to test the sign in each region. So next, get a test point in each interval, like -4, -1, 0, 2.5, 4. Those are test values inside each interval. Then test the sign of f of x in each interval. So at x equals -4, f of -4, if I use this factored form, I'll bring this down here for reference. If f of x equals this expression, then f of -4 is 3 times -4 plus 1 times -4 minus 2 over -4 plus 3 and -4 minus 3. And if you want to be thorough, you can. This is going to be -12 plus 1. This is -11. This is -6. And this is -1. And this is -7. And if you want, you can go through the motions here. This is 66 over 7, which is positive. But really, you don't need to do all that arithmetic. You really just need to focus on the fact that this is negative times negative over negative times negative, which overall is positive. So we can just focus on the plus minus signs if f of x is factored. That's key there. if this isn't factored, you can't necessarily use this technique, and then you got to simplify the algebra. But this was positive 66 over 7. So if I draw this again here, let's see, I'll just duplicate this really quick. Oops. I should have kept that -4. I didn't mean to erase that. F of -4 is positive in this region. So going through the other ones really quick, at F of -1, we're going to get negative times negative over, let's see here. When I plug in -1, I'm going to get -2 times -3 over 2 times -4, which is negative times negative over positive times negative, which overall is negative. So it's negative in this region. Or maybe I should just say less than 0, negative. At F of 0, we get 1 times -2 over 3 times, oops, come on, over 3 times -3, which is negative over negative, which is positive. So it's positive again in this region. F of 2.5, that is going to be, let's see, positive, 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 negative, which is negative overall. And then finally, at F of 4, it's going to be positive times positive times positive times positive, which is positive overall. So if we shade this in appropriately, this is, the graph occurs in this region, and then it's below the axis, and then it's above the axis, and then it's below the axis, and then it's above the axis again. And that's our plus minus sign chart for this function. Maybe I should put those minus signs below the axis there. There. Now, if you look back at our original graph of this, way back up here, you can see that that's actually what's going on here. We have above the axis on the left side, it's actually way up above the asymptote. And then we're below the axis until we get to -1/3. And then we're above the axis in between those values. And then we're below the axis between 2 and 3. And then we're above the axis again after that. So again, it does follow this plus, minus, plus, minus, plus sign chart. But we're specifically going to use that here to answer the inequality question. When is this strictly less than 0? Well, this is going to be less than 0 when the interval is negative. So for us, that occurs here in those two intervals. So f of x equal to 3x squared minus 5x minus 2 over x squared minus 9 is less than 0 if f of x is negative. And that will happen if x is in the interval -3 to -1/3, union 2 to 3. And that's our solution. That's when the graph is below the axis. So you can actually do this visually if you look back up here. You say, well, when it is 3x squared minus 5x minus 2 over x squared minus 9 less than 0 in the regions below the x-axis, which also happens to be -3 to -1/3 and 2 to 3. So you can do this kind of thing visually if you have a graphing calculator. You can obviously graph these and find the zeros and the asymptotes, and it's really based off of the zeros and the asymptotes. Now, what I want to do is, for our second example, I guess first I should ask if anybody has any questions. Does anybody have any questions on that? Plus minus sign charts. You can actually use that plus minus sign chart not just for answering the inequality, but to actually help you graph your rational function so that you know when it's above or below the x-axis.